Hi, welcome to my video on the review of constructions in geometry. And this review is done not as a quiz because it's very hard to mark. So you can do one question at a time and see if you can copy or practice bisecting an angle, constructing a perpendicular, etc., etc. So let's do number one. Construct an angle of 130 degrees using a protractor. So let's draw a segment. The segment can be any length because we just want to draw an angle. So let's mark this A, which is this point, and I want to, at A, construct an angle of 130 degrees. So what I'm going to do, I'm going to rotate up this way to have the 190 is up here. So 130 would be up here. So put the protractor at A along the line, and there's A there, and we mark off 130 degrees. So we're starting rotating up here to 90, 100, 120, 110, 120. So 130 is roughly, it's just an estimate right here. So we draw a line or a segment from A out to that point, and so we've constructed an angle of 120 degrees. Call that P, and call this ray over here, the point on this one, Q. So P, A, Q is 130 degrees. Number two, construct a circle with a radius of 3 using a compass and a ruler. So we have a ruler here. Let's pick up our compass, and we want to construct a circle with a radius of 3. So take our compass, place it at 0, and open it up with a radius of 3 centimeters. So there's 3 centimeters right there, and we draw a circle with a radius of 3. Put our compass, and let's put a dot there for that point, so I'll know where it is after. So let's say this point is right here. So put our compass at this is going to be the center of the circle, and here comes our circle with a radius of 3. And I want to, there it is. So that means any point, here's the center, any point on the circumference from here to this distance is 3. From center here to this point is 3. Number 3, using a ruler, compass, and protractor, construct a triangle ABC, where AB is 8, angle A is 95, and angle C is 55. Well, we have to draw AB, which is 8 centimeters long. So what I'll do is draw a segment. Here it is. And I'll mark A right here, and I got to make sure that it's more than 8 centimeters. I can use a ruler to mark off 8. Like this is 8 long now. I can go longer, and I could have gone from here to 8 right here with my ruler, because this first line, part of the angle, can be done with a ruler. Or I can take up my compass, place it at 0, stretch it out 8 units like this, 8 centimeters, and there it is, 8 centimeters roughly, and we place it at A, and we mark off for 8 centimeters. So whatever way you want to start this. So we have A, so that means we have AB, so this is B right here. Now we want to draw A 95 degrees, so we pick up our protractor and place it at A. Now if this is our triangle, 95 degrees, I could rotate 95, but so I have to go this way to get to 95 if angle A is right here. We place it along the line, And we start here and go up to 95, but there's 90. There's 95 roughly right there. So we draw a segment from that point to A. So angle A is 95 degrees. Now we want to draw angle C, but angle C is somewhere on this line. So that means we got to take, if we put angle C to be 55, we have to move it along like this till it hits 55 here. So we keep going. 55 is right here, right there. So if you do that and it hits right here, we have 55 degrees. Now that means this point, if we take a protractor away, we won't know where that point is. So the best thing to do is to take 95 and 55 and add them together, and that gives us 150. That means that angle B, the third angle, is 180 minus 150. So angle B is going to be 30 degrees. So at B, I construct an angle of 30 degrees. There it is. Now we're rotating up here, 30 degrees. We're not going rotating this way, so 30 is right here. So we line up, and the protractor is long enough to do it. I did not have to use my ruler, just the right length. And here it is. Right to there. So we have angle B is 30 degrees. That means that C is this point right here. So that means that this is 8 centimeters. And now that means that this is angle C here. So this angle C must be 55 degrees. So just to check to see if we got it done right, I'll place my compass on angle C, or protractor I should say, on angle C along the line. Perfect. It's right at the vertex. Here's angle C here, and so, and notice the angle is coming right down through here, 55 degrees. So everything is okay. We got the construction done. And let's do some more. The videos are done in the order that the questions are done on the review in the order of the videos that I did in the unit. Numbers 4 to 9, use a ruler and compass only. Construct a perpendicular to XY at A. Construct a perpendicular to XY at A. So, we'll take it at A. So we take our protractor, place it at A, and we'll cut XY at 2 locations. One is there. Now if I want, I can just do this, or I can go all the way around. It makes no difference. So I cut XY at, say, B and C. So I take my protractor, and I have to take a radius of my compass more than half of BC. So that's more than half of the length of BC. I draw an arc, put my compass at B with the same radius on my compass, draw an arc, and the two arcs intersect, and let's say is at E. So I join E to A, make it a segment. So now I have a perpendicular to XY. There's the perpendicular 90-degree angle, and we just check to make sure that's a 90-degree angle at that point. Place the protractor right along the line at A, and 90 degrees is right straight up. So we did draw a 90-degree angle with a compass and a ruler. Number 5, bisect PQR. This is PQR, and bisect RQT. So what I'm going to do to bisect, I'm going to take my compass, put it at Q, and because I'm bisecting both angles, I'm going to use the same arc for both angles. So draw an arc. So here's cutting PQ, cutting RQ, and I'm also going to use the same arc to cut QT. So there's the same arc. Now I'm going to cut PQ at F and cut RQ at T and cut, oh, T is already here, so I better use a G. Can't use the same letter because it gets mixed up, and cuts QT at X. So I want to bisect this angle here, PQR. So I place my compass at G, and I have to take a radius greater than half the length of FG. So that's greater than half the length, and I construct an arc. Place the compass at F, which is on the other ray of the angle I'm bisecting. Draw an arc. The two arcs intersect, and call that C. So I join C to Q, and that ray or segment will bisect the angle. So there's the angle bisector. So whatever size this angle is, then we have a bisector. So let's just see what size that angle is. So that angle is, notice we're rotating up this way. We're rotating, this is the angle. So when we measure this angle, we have the angle approximately 140 degrees. So that means the angle PQC and CQR must be 70 each. So let's see if they're 70. So angle PQC, right straight up, there it is, the rotation. So that's 70. And that means that this angle must be 70. So that's 70 and 70, because the big angle is 140. So this one must be 70. And again, just checking. There it is, we're rotating this way. So we're rotating 60, there's 70 right straight down through. Now we want to bisect the other angle. So we have the, we have the arc. I'm going to use this arc. So I place my compass at X, and this radius is more than half the length of, we got to go more than half the length of XG. So this radius of my compass is more than half that length. So I draw an arc. I place it at G with the same radius, and I draw an arc to cut the previous one. That's done. So this angle, and I'm going to use, again, I'm using my protractor as a straight edge. So there's the angle bisector. So let's, now this angle here, this angle FQR is 140. That means RQT must be, this angle here is 40. So these two angles must be 20 each. So let's see if, let's call this, give it a W. That means WQT must be 20 degrees. Let's see if we're right. If we got it done right, we have it. There we go. To make sure. Oh, my protractor was turned over. I thought it was, let's see if it's 20. Perfect. We're rotating up here. So that's 20 there. And this must be 22, also 20. I gotta be careful when I say 22, 20 also. So there it is right there, rotation. That's 20 degrees from here to here. So that's 20, that's 20, and this big angle here is 40. 40 and 140 makes a straight angle 180. Now let's do number 6. Show that X, so show that AX is an altitude, a median, and an angle bisector of this triangle. So here's the triangle A, B, C. So we're going to show that AX is an altitude, a median, and an angle bisector of the triangle ABC if we have AB is equal to AC. These two sides are equal. Well, I can measure them, or another way to do it, to measure them, is to put the compass at A and stretch them out like this to B. Now it's going from A to B, I got that length. So that means if I go from A to C or C to A, I should have the same distance. Perfect. So AC is equal to AB. So because of that, that means that this segment going down here is going to be, let's see, an altitude. So how do we know it's an altitude? Well, let's take a compass at A and cut BC at two locations. We're going to cut B and BC at two locations. Those two locations we call it D and E. So we have two locations. So we place our compass at E with a radius of greater than half the length of DE. So this distance greater than half, and there it is, greater than half. There we go. We draw an arc down below. We put it at D. Draw an arc down below to intersect. There it is. And so join them up where they intersect. So what happens, this is an altitude. An altitude is a segment that leaves this vertex and goes perpendicular to the opposite side. So we just constructed a perpendicular. So when I join A to this arc, let's say this arc is W. So when I join from here to here, notice I'm passing right along AX. So AX is an altitude segment that leaves the vertex perpendicular. So it's perpendicular there. Now I want to show that as a median. A median leaves the vertex and goes to the midpoint. So I want to show that this is a midpoint. Well, I can do that by measuring, or I can do that by construction. So if I take up my ruler and measure like this, I have roughly 40 centimeters, or sorry, 4 centimeters or 40 millimeters. So if I measure this one, I also have a 40. And another way to do that is to place your compass at C and pick a radius more than half the length of, so here's B to C. So I'm going to take a radius of the compass more than half the length of BC. So let's take it smaller. So right here. And we draw another arc coming from B. And when we do, it intersects there and there. So the segment, so if I take my ruler, notice if I put my ruler on these 2 points here, if I call that F, and I call this point G, so if I draw a segment through F and G, it is the same as passing through AX. So AX, this is a midpoint because I constructed the perpendicular bisector. Bisector means it's going to pass through the midpoint. So X is a midpoint, so that means AX is a median. A median leaves a vertex going to the midpoint of this side because XC is equal to XB because of the perpendicular bisector, and that's a midpoint. Now we want to construct an angle bisector from angle A. And so we open up our compass to cut the two sides of angle A at two locations. So here's it at A. So I'm going to draw an arc to cut AB and AC. And I can swing it all the way around if you want. Oops, just a little bit. Here we go. Make sure you can see what I'm doing. There it is. Now, I'm going to label those two and call this M and call this N. So I'm going to take my compass and place it at N and a radius greater than half the length of MN. So this is the radius of my compass greater than half. So I make an arc. So I put my compass at M and I make an arc, cutting the previous one. Done. So there it is. You can see it. I pick my ruler and you can see that the point of intersection which if you want to call that O, from A to O, draw a segment, there it is, and that's also AX. So AX, this is an angle bisector, we just bisected the angle, so AO is a bisector which is part of AX. So because these two sides, AC equals AB, this is an apex angle, this is an isosceles triangle from this apex angle where the two sides are equal, and altitude, perpendicular, is a median going to the midpoint, is an angle bisector. An important thing that we do in geometry. Okay, construct an angle of 112 degrees. Again, we're only using a ruler and a compass. So we got to construct an angle, so let's make a segment. Let's draw a segment to construct my angle. So here we are. Now I want to make an angle of 112 degrees. And notice 112 and a half, take off a 90 is a 22 and a half. And notice 22 and a half is a 45 divided by 2. So if I can construct a 45 degree angle and bisect it, then I'll have 22 and a half. So let's see. Let's take this point right here and call this point A. So I'm going to construct, I need a 45 degree angle, and a 45 degree angle is in an isosceles triangle. So at A, I'm going to make a right angle at A. First of all, I'm going to bisect the segment, I'm going to cut the segment into at two places, because I'm going to construct a 90 degree angle at A. Let's get a right angle first. So open up this, cuts it at B and C. So place the compass at B and C with a radius greater than half BC. Draw an arc. B and C, we draw an arc. So I've constructed a perpendicular at A. So we have a right triangle. We have a right angle so far. There it is. There's the right angle. So now I have a right angle. I want an isosceles triangle. So now I'm going to mark off two sides equal. So let's bring our compass in, and the two, I can take this arc right here like this that I just did and make, when I cut here like that, and I swing it around right here, so these two distance, this distance of C, and call this P. So I did my arc, so that means AP is equal to AC. So this is a right isosceles triangle. So if I join P to C, I now have an isosceles right triangle. So with two sides equal, that means if this is a 90, this angle is a 45, and this angle is a 45. But another way, I could bisect the 45 and put it here, but I have a right angle. I can also make it easier by drawing a perpendicular from A to PC. So this is the equal distance again. So take C with a radius more than half of PC, draw an arc, put it at P, and draw an arc. So what I've done now is that I bisected the angle. PAC is bisected by this segment or ray. So that means that this is a 90 degree angle, and I did this construction with these arcs. This is 45 and 45. This is 45 and 45. So there's a 90 degree angle here. So if I could bisect this angle right here, then I would have 22.5 on this side, 22.5 on this side. So 90 and 22.5 would give me the 112. So it was convenient that I have this arc drawn to make the right angle. So I'm going to use, again, we did A, we drew the arc before right here. So now I'm going to take this point and draw an arc. And I'm going to take from P and draw an arc, intersecting the previous one. So what I've done is that this ray or segment went out through here. So this is a 45-degree angle here. This is a 45. Now I've made this angle 22.5. I've made this angle 22.5. So rotating from here, that's a 90, and 22.5 there. So this is 112.5 degrees from here to here. And we did that with a compass and a ruler. Now we have another one to do. Keep reviewing, keep practicing. Construct a segment through the midpoint of EH. So we have to get the midpoint of EH, let's say it's right here somewhere, parallel to HT. So it's got to be parallel like that through HT and going through the midpoint of ET. So we got to start here to this midpoint, parallel to HT, and passing through the midpoint of ET. So what we're going to do, I'm going to do, is find the midpoint of ET. So the midpoint of ET is found by constructing the perpendicular bisector. So you make an arc, you put it at E, and you intersect the previous arc at two locations. That's done. And we join up the segment through those 2 points. So let's call that A and B. So AB is the perpendicular bisector. So AB is the perpendicular bisector of ET. So that means that G, if you want to call it that, G is the midpoint. So we'll do the same thing again with HE. We'll put it at E and we'll construct a perpendicular bisector. So here we go. Make an arc from E, make an arc from H, and here we are. Now we'll join them up. Let's call this, let's say P and Q. So if I join P to Q, where it intersects, so this point right here, if you want to call it X, so X is the midpoint. We did the perpendicular bisector, so X is the midpoint. Now I'm going to draw a line through X parallel to HT. So what I'm going to do is construct, I'm going to take this angle here, EHT. I'm going to copy this angle at X. I'm going to copy this angle right here. So I'm going to make a pair of corresponding angles equal, so I'm going to get a pair of parallel lines. So at H, put my compass, and I'm going to make an arc. Cutting HE. So I'm going to cut HE at, pick some more letters, S and T. So with the same radius, I'm going to put my compass at X. Make sure it's at X. Again, approximate. We draw an arc. There it is. So we go back and we go from S to T. S to T is this segment. So from S to T, or T to S, it makes no difference. S to T, the same distance. S to T, there's the radius. Or S to T or T to S is the same. So we place our compass right here. And we're dealing with this arc, which is similar to this one, the same distance, and it cuts right here, and let's say it cuts at Z. So we'll join X to Z. There's the parallel line, and let's see what happens. So there's the angle. EXZ is equal to, so this angle right here, and I'll shade it in. There's this angle right here. I made it equal to this one by copying this. Take the angle H, and I copied it at X, this angle here. I made this line, so that line is now parallel to that line. There's the parallel lines, XG and HT, and it passed, notice, it passed through the midpoint. So I did the midpoint, and I constructed this line, goes through this midpoint that I constructed, made it parallel to HT, and notice it passes through G. And also, there's the theorems in the math that this line through this midpoint parallel goes through this midpoint, yes, but whatever the length of this segment is, this one, HG, is half of HT. If you take a ruler and measure it, just check it out. Okay, and let's continue. Construct a rectangle with sides of 6 and 4. A rectangle is similar. A rectangle looks like this. A rectangle got 4 right angles, and if this is a 6, the opposite sides are equal, and this is a 4, and this is a 4, and we got right angles. 4 right angles. So what I'm going to do is that I'm going to draw a segment so I can pick up the rectangle. Here we go. We can go wherever we wish to get the length. So I can go from 6 is 30 to 90. I can go further and cut it off. So if I take, I can put wherever I wish. There's A. So I can take my ruler and make sure I got 6 drawn correctly. So put my compass down at the end, wrote 6 units, 6 centimeters, roughly right there. There's 6 centimeters. So place my compass at A and cut off a length of 6 centimeters. I did it with the ruler just then, but we'll make sure. There it is. So now I can do 2 right angles here. So let's take this, let's call this AB. Let's call this one B. So at B, I'm going to construct a right angle. So bring my bring my compass in. So at B, I'm going to make a right angle. So I'll make an arc there. There it is. And notice this is on this line, so there it is. I could extend it, but because I'm on this line, it's already extended. I'm also going to use the same arc for the other right angle at A. So I don't have, there it is. Now, at this point, with a radius greater than half, I have to go greater than half this distance. And there it is. Put it at this point, and I have, if I join these two up, I'll have a right angle. Also, because I drew this arc right here the same, I'm going to take my compass and put it here, make an arc, and place my compass here and make an arc. And I now have 2 right angles. So from here to B, I have a perpendicular. And from here to A, I have a perpendicular. So this perpendicular, remember AB, I made it 6 long. So now, and there's a right angle here, and I have a right angle here. So what I can do is, the other one is 4, so I'm going to measure off 4 centimeters. So take my ruler, place my compass down, and I'm going to draw 4 centimeters. Mark off 4, there's the 4. Oh, paper's moving. Apologize for that. Place it at B, and draw, mark out 4. Place it at A and mark out 4. So there's 4 up, and that's 4 up, that's 4, and that's 4. So if I join those 2 points, right where they pass through, so this is 6, 6, 4, 4. I got right angles here. So I have a parallelogram with opposite sides equal. So these sides are all parallel, or these opposite sides are parallel. I gotta be careful. And these two sides here are parallel, and these are parallel lines. So if that's a 90, then that's a 90. That's a 90. This is a 90. So I have a rectangle. Now, number 10. Find the incenter of triangle ABC. An incenter is, if you remember correctly, is the point where the angle bisectors meet. Where the angles bisect. Incenter is inside. So there's going to be a circle inside of this triangle. So I'm going to construct the angle bisector. First I'm going to do angle C, the angle bisector. So here comes the angle bisector. Draw an arc to cut BC, and I'll label those points just to keep it straight. A, B, C, D, E. So I'm going to place my compass at D and E, and a radius greater than half DE. So that's the radius. So D to E, this radius is more than half. So I draw an arc. Place it at D, and I draw an arc. So it's I just touched. So I just had enough. So let's make it a little bit more. So now this DEF, let's call this F, and join up CF. C to F. So we have an angle bisector. So that's one angle bisected. So this angle is equal to this one. Now I can bisect angle B this time. So all the angle bisectors will meet at a point called the incenter. So let's take angle B, and whatever distance I want, just keep it half decent. And you wouldn't want to go way out like that, too far. So we just come in, and so we cut AB at, let's say, G and H. So we take our compass and make it the distance greater than half the length of, so it's got to be greater than half. So if you go from H to G, you have it greater than half because you have the, so you draw an arc from H, and you draw an arc from G. Two arcs intersect right there. So there's the two arcs intersecting, and we make it an eye. So we draw BI, and that'll be, BI is bisecting angle B. And we extend it. So notice we extended it. They're intersecting right there. Now if I draw this other angle bisector at A, if I draw the angle bisector for angle A, it's going to go through this point. But I'll just do that too, just to make sure. Here we go. Place the compass at A, and I'll cut AF and AE. So there's AF and AE. So place my compass at E with a radius greater than half the length. So I got to take a greater than half the length of this segment. So it is. So we draw an arc. Place it here. We draw an arc. So the two arcs are intersecting. So from here to A, this is an angle bisector. So the three of them are meeting at this point. So that means this is an incenter, and an incenter, that means there's a circle that'll be drawn that'll touch each of these sides of the triangle. So if I take this center and I go just touching the sides of the triangle, just touch the sides of the triangle. In other words, it's going to be tangent. That's the answer to the question down below. So there it is there, just touching. Let's see if it's going to touch AC. Pretty good. It's just touching. And we go down, and when I keep rotating, it should just touch CB. Just touching. You can see it. Huh? Move my hand so you can see it. It's over the top. So it's just touching. There it is. Go all the way around. So notice that this circle, and if this center, whatever this center is, it could be Z, and this is Z center right here. That means that this circle is an in center. This center's Z is an in center. What does it mean? That the circle is touching each side of the triangle. This circle is tangent. So each side of AB, this side AC, AB, and BC. So it's tangent right here. This tangent right there is tangent. And this tangent right there, touching it at one point. And this tangent, that's D there. So it's tangent here. So these points are right there. These are the points where the AC cuts a circle at one point. So they're tangents. The sides are tangent. The sides of AB are tangent to the circle. In other words, touching the circle at one point. So it's an in center. So that's the total review of the unit. Again, it has many more questions. We just pick a few. And this ends the video. And if you like my video, also ends the unit on constructions. But you can always pick up more questions and practice following my videos. If you like my video, click on the like button, click on the subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that I have on my YouTube channel called Math Fully Explained. Notice one word, Math Fully Explained, my YouTube channel. Thank you for viewing my video. Hope the video helped you. Bye-bye.